Hi everyone, so it's great to have you all here again. This is our third or fourth virtual meetup, and it's great to welcome some of the multi-cloud attendees from outside London. Welcome to everybody that attended the quiz last week, and Rick's talk on how to get the maximum number of containers into ECS instances. Today, we're going to cover a little bit more on the GCP side of things, and we're going to talk about machine learning. So first of all, I'd like to introduce our sponsor, which is Doit International. And please let us know in the chat where you are on this map. So Doit's a cloud consultancy working with you to maximize what your cloud can do. We can help with cost optimization and architecture across multiple clouds, AWS, GCP, and Azure. We can provide production support and can escalate issues with cloud providers. You can see, and you should check out our support stats on Doit International /stats. We're very transparent about how we're dealing with tickets, the throughput, and how quickly we respond to customers' queries. And we can offer all of this at zero cost, and that's because we've got a unique pricing model where you are required to move your billing accounts over to Doit International. There's no additional cost to you. You would pay the same as if you were transacting directly with your cloud provider. But the way that we make our money is by taking a commission based on your spend that we get back from the cloud providers. We're a Google Premier Partner, and I want to give congratulations to our US team on winning Partner of the Year for North America, so the 2019 North American Reseller of the Year. So the sales pitch is over. We'll move on to a little bit about what we're going to talk about today. And so with this talk, I'm really targeting two main groups: engineers. And if you're an engineer and you're tuning in, it's going to be helpful if you know a little bit about what a machine learning model is, but not necessarily how to build one. The second group we're going to talk about is data scientists, and it'll be really helpful if you're interested about infrastructure, but there's not really too many strong requirements about your understanding. And so with those two groups, we're going to cover both sides of the ML coin, this problem. But also, please make sure if you've got any questions, then there's the question and answer section in Zoom just below on the screen here. I'm hoping that we're going to get some good back and forth between those two groups, and maybe we can all learn something there. So I want to talk about one of the major tools that we'll be talking about today. We're going to talk about TensorFlow Extended, which is a suite of libraries in the TensorFlow ecosystem, which help you address how to build machine learning pipelines in production. We're going to talk about Kubeflow, which is an application that runs on Kubernetes and orchestrates machine learning workloads, training, evaluation, serving, those kinds of things. And as I've said before, we're going to be working on Google Cloud Platform, but most of what we're going to cover is very amenable to running on AWS and Azure. All of the projects that I'm talking about are open source, so it'll be very straightforward to take these applications and install them on the cloud provider of your choice or on premises. Yeah, so this is a photo I took in Xi'an in China in 2008. I think it's a good sort of metaphor for how a lot of some machine learning models and how when you build all the software around them, how your model can end up. It's duct taped together, it's held together by string, and it's difficult to get from A to B. This might work once, twice, but it's not a long-term recipe for success. And delivering models to production is still a challenge in the machine learning sphere. And I think a really good analogy for where we are with our machine learning pipelines is if we look 20 years ago at where we were with continuous integration and deployment. I think a lot of the tooling that exists there now is just necessary to be productive and to keep your code live. And I think some of the tools that we'll cover today, and others are available, are really helping to address those sorts of challenges. And that's where I think a lot of the inspiration for some of these tools might come from. So we're going to build up a motivating example to help sort of season some of the ideas that these pipelines present. And so I want you to imagine tonight that we're all in an ML engineering team of a new social media startup focusing on books. Growing fast, which is great. We want to grow the business and we want to improve our performance-based KPIs. What we're tracking is active members, the number of members on our site, and the time that they spend on the site. So we've got two sort of coarse-grained metrics that we're monitoring. We want to enhance our users' experience and stay focused on their needs. That's how we're going to build our business and build a sustainable business. We've got a problem. There's some sense of dissatisfaction on the website. There's an increase in users reporting bad posts. Some people are posting irrelevant commercial information onto our book club message boards. The users are getting frustrated. It's making it difficult for people to share their ideas. And the time on our site's declining. And so we're concerned that even though our user numbers are growing, that some of the core KPIs that we're looking to track aren't going up. So we want to drill down into this. We look into the users that are being reported as posting irrelevant material. We don't have a lot of data on them. Our website's quite new, but we do have some profile pics that they've posted in. So our community team pull these together for us and present us with this. And so the team noticed that some of these images are computer generated. And I'd be really interested to open the poll and get some feedback from you guys, because I think it's actually really tough to see which ones you think might be computer generated and which ones you might think would be real. So I think Rick and Jason are going to open up the poll and we can get your feedback. Well, I don't think I can vote because I'm a thingy, but yeah, we'll see the guesses as they come in. It's multiple choice, so it's not just one.
Yeah, for any of you out there, if you haven't seen the poll icon at the bottom there, click that and then you'll get the polling come up.
Awesome. Cheers, Jason.
Results coming in now. Keep it open for a few more seconds. Vote for as many as you want. Tell me which ones you think are fake.
Quite like the visualization, it moving around. I thought for a minute people were changing their votes, but it's the scale changing, of course.
Yeah.
So the most popular one, photo number 3. Yeah, I guess the reflection in that is a bit of a giveaway. And photo number 6. Yeah, I guess the right hand, sort of her left hand eye looks a little bit skewer, maybe. Cool. So actually, only one of these photos is not a fake photo. Number 2 is a real photo, but all of the rest of them are fake.
I've got the results in for you here, Darren, if you want. There.
Yeah. And so yeah, photo 3 seems to be the most sort of likely to be fake photo, closely followed by photo 6, 13 out of 22. Photo number 4, sort of third place. I guess the rest, maybe 4 and 8, seem quite similar, and the rest maybe a bit lower down. So it definitely seems that the top 3 or 4 is photo 3, number 1, 73% of people who voted. Photo 6, photo 4, photo 8. So interesting that people would think that the child is. I guess maybe the symmetry on photo number 8 is a giveaway, but that is a fake photo. Photo 2 isn't fake. So all of these photos were generated with a type of deep learning model called a GAN, a general adversarial network. It's quite a complicated deep learning model. If you want to know a bit more, our head of AI, Gad, did a presentation last year, and we're going to put just a link to that YouTube video in the chat for you to maybe save and review later. It might be a good introduction. So anyway, we recognize that there's something not quite right with these images. We recognize that they're computer generated. Can we use this information to address the business challenge that we have around finding people and addressing the challenge of people sort of joining our site for nefarious purposes? So we go on to Kaggle, and Kaggle's a data science and predictive modeling competition platform, and their sort of tagline is making data science into a sport. They actually recently hosted a deepfake challenge with a $1 million prize pool up. It's just closed on Kaggle. And this was actually slightly different data set. It wasn't images, I think it was video, but you know, it's an interesting space to be looking at and working in. And so we look into the deepfakes that might be available. And there's a user called, I'm going to try and pronounce this to my detriment, Zululu, who's posted up 140,000 photos. 70,000 of them are real photos from Flickr, and 70,000 of them are based on a machine learning model, a GAN that he's trained on NVIDIA hardware to provide fake faces. So maybe we can leverage this data set and use a model to address our needs. So the kernel of all machine learning pipelines is the ML code. And when you're building an ML model, you might work in something like Jupyter Lab. So Jupyter Lab is an interactive environment. I'm working here in Python and using TensorFlow, as you can see. So we can run on a small slice of our data and build a model. If you're familiar with TensorFlow, you'll see here that we're using a few convolutional layers in our neural network. That allows us to sort of generalize the model well and become invariant to small changes in the image input. So, for example, moving people across different areas inside the image shouldn't change the prediction. You know, a real face is still a real face, or well irrelevant of exactly where it lands in the image. So, a convolutional layer is helpful for that sort of thing. We won't go too much deeper into the modeling side of this. This is actually a very straightforward architecture, and the state of the art is far more complicated. The point of the talk today is more about fitting all of the other pieces around that model. So we also take in a small slice of our data, and we've built the model. And what we want to do is just take a look that the data seems to make sense. We've got a photo there. And then what we can do is train a model. So we take multiple steps through this small training data set. At the end of that, we make we do an evaluation using a held out set of data. And as we update the model and improve its parameters, we hopefully improve the predictive power. So we're doing 10 iterations through all of the data here. And we're running on a small data set. This might be something that you would run on your laptop. And as you can see, our predictive performance is improving, certainly on the training data, but also on the right-hand side on our validation data, which is the held out data that we can actually report on realistically, because it's data that the model hasn't seen. So we've managed to improve this a little bit. We've run a few training steps. We could run it for more, and it would improve. But this is maybe looking positive. So we can save this model to disk, and then we can report back maybe to our head of growth that we've maybe got a lead in to help us make some good step forward. So they're really impressed. We've managed to build a model that can probably do better than human performance. Like one of the challenges, one of the sort of thresholds for a lot of the machine learning models is surpassing human performance. And I think based on the poll, I was a little bit unfair because almost all of them were fake. But I think it's quite difficult to choose to achieve a high level of performance with this kind of task. But it's something that a machine can maybe look to approach or even exceed. And once you reach that kind of scale, then there's a lot of value in machine learning because you can scale that up and address large problems like we could across our growing user base. So the growth team are really excited. They want to take this model and they want to bring it into production. We've got it running in our notebook. We're happy with the performance. But one of the challenges in machine learning is not just building the model, it's also all the other pieces that fit around the model. And so there are lots of things that we need to think about as we take a model to production to address the needs of the engineers that we're working with and to address the requirements that we have to use the model. So the business wants this in production yesterday, and there are a few use cases that they have. The first one's around user sign up. When a user signs up, they provide a profile picture. It'd be really good if we could take that picture and provide a prediction back as we're running up the service to get a quick feedback and maybe understand and take some steps to further validate that user if we think that they're likely to be fake. Our confidence bounds for that, our threshold needs to be incredibly high. We want to have a very high confidence that the user is fake to provide, if we want to provide those extra checks, because that's more friction for people onboarding onto the platform. So we might want to say 5% predictive probability that the image is fake before we would decide to take some extra steps with that user during the sign-up workflow. Another use case might be to understand across all our users how many we think could be fake. Our criteria here are a bit different. We're just interested in across a very large data set, how many of our users are fake. And so we wouldn't necessarily be worried about what's called false positives. We'd be more concerned about just a poll effectively of how many users might be fake, and that might be helpful for the analytics team to sort of report on how many active users we have more effectively. So our users are growing exponentially as well. Our site's young and we want it to grow over time. We want to make sure we deliver a model that's going to be scalable. And so we want to build a pipeline that can run on our small data today, but as our users double over time, we want to be able to run it on increasingly large data sets, and we need an architecture that can support that. We need to do feature extraction, we need to process the images. There are lots of steps involved between getting this machine learning model trained and using the model to address our two use cases. We also want to monitor how the model performs over time. That could change, and as our data changes and as we blend the data that we have in our repository, our image profiles of the users, and the images that we've got from Kaggle, we might want to see how our model performance changes. So this is really the space that TensorFlow Extended's operating in. These are the questions that it's answering for us, and these are some of the challenges it's addressing. So TFX comes from Google's experience of building and failing to build in some projects models over a lot of different projects over many years. It's a Lego brick approach to building a pipeline of pluggable components which are easy to customize and but broadly applicable to most tasks. TFX pipelines are DAGs, which are directed acyclic graphs. And this is just a nice mechanism for expressing the dependencies between different parts of your pipeline. So this is maybe what a DAG might look like. TFX expresses the pipeline, but the work actually gets done by your orchestrator, which sits underneath TFX. TFX currently supports 3 orchestrators: Kubeflow, which is what I'll show you briefly today, also known as AI Platform Pipelines on GCP, recently launched into beta. It runs on Kubernetes. It's also, Kubernetes is available in most tech teams, so a deployment of Kubeflow, if you've got Kubernetes already, is probably not that far away for you. Kubeflow is designed for running machine learning pipelines. So it's a good choice if you've got multiple models in production. It is a little less mature than the other choices, and so there's maybe a bit of a question there around which might be the best one to go for now. But I think it's definitely where you might want to place your bets, for the future. Because Kubeflow runs on Kubernetes, getting and serving your models is also a breeze. Serving is putting them into production so that you can get predictions out of them. For example, for our workflow around sign-in, you want to submit an image and get a response back. That would be serving, like a prediction. And so deploying your model onto Kubernetes is really straightforward. So that might also be a good thing to think about. The other one of the other orchestrators we could use is Apache Beam, Cloud Data Flow on GCP, and it's great for processing data sets in parallel. TFX can also be used. So TFX also uses Beam for distributed data processing, and so other orchestrators use Beam as well to orchestrate their data processing work. The nice thing about using Beam as an orchestrator is you can run it locally, and that can be really helpful when you're building your pipeline to sort of iterate quickly, get your code working as expected, kind of like we were in the notebook, and sort of get to something good. It can also be good for distinguishing between a problem that you might be having, which is pipeline related or TFX related, and orchestrator related. And so I found that quite a productive way of working before sending a model up to Kubeflow for training to fit the pipeline. Airflow is the third alternative. Airflow is super popular and built by Airbnb about 4 or 5 years ago. Also, it's got a very strong user base in data engineering teams. If you've already got an instance of this up and running, then it would be really straightforward and quick to start using TFX today. So that's another opportunity. So I want to sort of talk through each of the TFX components here and sort of like line them up with our problem set and kind of give you a sense of what each of them are doing for us. So example gens are all about obtaining your raw data. So that could be in cloud storage, in CSV, JSON, or TF record format. You could access your data in BigQuery and Presto. All of the methods I've just described are supported. If you wanted to access your raw data someplace else and you've got another repository, you could totally implement your own component, and that's all you need to provide to make use of all of the rest of components that we're talking about. So you get some flexibility. And as you can see here, this is where our raw photo data would go into the pipeline. So this is the starting point. Once we've ingested our data into a pipeline, we probably want to validate it. And the statistics gen, schema gen, and example validator components work together to achieve that. Statistics gen looks at the features that we have and calculates the statistics across those features. Schema gen can infer a schema, or you can specify one to be enforced. And then example validator allows you to filter out bad data that might have been corrupted, data that that falls outside of bounds that you expect for your model. And you can either alert on that or filter that data out. This is quite a common challenge for machine learning, in general, is finding the data that is correct and hasn't been corrupted. Once you've sifted out that bad data, you go on to transforming the transform step. So this is all about preparing your data for training and the feature engineering part before we start training a model. So this is making the data available to the model in a way that it can understand. So this is like taking a JPEG, which is a string of bytes, converting it into numbers that a mathematical model like a deep neural network can use to train and make predictions. One of the things that TensorFlow Extended locks in, by specifying the transform step like this, part of the contract that you get back is that your transform steps that you run in the training time are the transform steps that you'll be running when you serve your model and when you evaluate your model. So this can often be a sort of a situation where you might get some skew when you're fitting a machine learning pipeline like just in a notebook on its own. There's nothing that locks down in this notebook how I've done my transforms on the data that I've read in from disk. And there's nothing to say when I evaluate my model, I did something subtly differently that isn't then a fair test. Even further down the line, when we're back into the serving step and we're in production, getting our sign up workflow through. It's even more difficult to lock down those transforms and make sure they're consistent across these three pieces. And so having that built into the pipeline really offers value for you and over time, over many training steps and many model runs. Once we've built the model and we've transformed the data, we're ready to go to training. So TFX, if we're using Kubeflow as an orchestrator, you could totally do your training there. Today, I've used Kubeflow to call into AI platform on GCP and request the training to happen there. So we're training in a completely serverless environment. You could totally also use something like SageMaker to do this. I believe there's a SageMaker connector coming or already available for Kubeflow. And so this allows you to have a choice between running on your existing Kubernetes cluster for your training or to offload that to a cloud platform and AI environment. So once you've trained a model, it's really important to evaluate it. The evaluator component evaluates metrics that we're interested in tracking on our model. So obviously it's the metrics that are important to you for your business reasons. Like as we talked about, for the sign-up workflow, we might want to track a slightly different metric than just accuracy. We might want to track our false positive rate because we're really interested in optimizing that and making that as good as possible, rather than just how often we get our predictions right. Another component, another part of the sort of this picture is once you've evaluated your model, you have a choice about whether you want to release that to production. So you can express an absolute sort of threshold under which you won't release the model. Say, for example, it needs to be 80% accurate or we don't go to production. An alternative, which I think is a bit more scalable for your pipeline, is you can test it against an old model, the model that's currently in production. Evaluate both models on the same evaluation data. So read the old model out from disk, take the model that you've just trained, evaluate them both on the same data. If the new model outperforms the old model, then you're good to go. If it doesn't, then you probably want to stay with your current model. Another piece of the evaluation picture is a model that's just been, a component that's just been made available in TFX, I think this week. This is called the infra validator, and what that does is it's more like an integration test. It's making sure that the model that you've trained is actually going to work in production. So it'll deploy an instance of your model to a Kubernetes cluster. You can make some requests to it, make sure everything's coming back as expected, and if it does, you can output what's called a blessing. So evaluator and validator and infra validator both output blessings. So they sort of say this model is blessed. I guess they have to come up with some sort of verb for that. That's the input that the pusher will then take to decide whether a model is valid to be released. I just want to show you a little bit of like the rich output that you get from the evaluator component across all of the different metrics it can calculate. So you can see a large array of different metrics that have been calculated for this model. This isn't the model that I built. This is the model I think Google uses as an example. I think it's around taxi tip prediction. We can also evaluate our data in different buckets, different dimensions across our data. An example maybe for our use case could be we might want to see how our model performs on male users versus female users, or in different age ranges across our users. Maybe we perform very poorly on children. That would be something for us to look into. Maybe we perform very well on older people. And understanding how our performance metric that we're looking to track, say accuracy, is across all of those users is really interesting to us, and you can see some variation in the pictures here. So once we've evaluated a model, okay, cool, thanks, Rick. So there's a question come through: is it possible to run SKlearn models as well in TFX? Yeah, I think TFX. There are some examples with XGBoost in the examples. I haven't seen any for SKlearn. But I think that's the kind of thing that's definitely coming further down the road. So other ML, it's not completely fixed into the TensorFlow ecosystem, but as far as I know, unless anyone in the chat knows better, I don't believe SK models are currently supported. They may, however, be on Kubeflow though. So TFX is a higher level of abstraction than Kubeflow. There might be an opportunity if you wanted to sort of use some of this tooling with SKlearn to do that on Kubeflow. Once we've blessed the model, we want to push it out to production, and so. We've evaluated the model, we've made sure the infrastructure is going to work, and now we want to make it available, possibly release it to production. And that's what the pusher model is all about. The way we would do that is we take the saved model that I showed you and move that to probably cloud storage. And from there, we could run TensorFlow serving, for example. That's a very standard way to host a TensorFlow model. You can also host other types of models in TensorFlow serving. Also, if you're targeting TF Lite, like mobile applications, or the browser, TFJS, those would also be valid endpoints that you could push a model to. So when we build a pipeline, I want to show you this in code, just to show you that it's pretty straightforward to put this together. So the example that we just had from left to right, we've got our import example gen, which is the raw data we're reading off GCS and pulling in to get started on our pipeline. This is what that looks like. You can see we're using a train and evaluation set with a ratio of 3:1. So 25% of our data is held out for evaluation. We then move on to the validation stage. We've got those 3 different components there working together to do that. You can see each of them feed into the next. We're then going to do the transform step and get to training. You can see we've got some parameters for Google Cloud Platform there. We then want to evaluate our model. And we calculate a collection of different performance metrics for that. And then once we've evaluated it, if we're successful, we want to push it out. So this is a nice sequential piece of code that just builds up the graph that we see over here from front to back. So it's sort of, I think it's nice just to motivate this. Some people work better with code sometimes. Once we've trained the model and we've pushed it out somewhere, we obviously want to serve it and get predictions. That's what TensorFlow serving is for. It's very good at that. It's a lightweight, scalable infrastructure. Usually you can deploy a model and using a Docker container, and it supports canary deployments, so you can have different versions of the same model available. I've used Google AI Platform for deploying my model, and I can show you sort of an example workflow of having a model deployed to production that you could then call and get some predictions back from. So if we go into the Google Cloud console, we go into AI Platform, and we go down to models. We can see I've got this fake faces model. I've got a single version installed. And then I'm going to show you in a Jupyter notebook what you could do. But this is the kind of thing that your engineering team in their website sign-up workflow would call into. This is sort of the REST API call that they would make to take a user's, profile picture and come back with a prediction that we could then use to maybe take some extra steps if we wanted to. And so we're just, I've got some images here on disk as an example here. So if you just took those images and then make some requests to the API. One of the nice things about Cloud AI Platform is I'm getting a few pop-ups here, excuse me, is that it scales down to 0. So you can specify to have a single host always available to serve your predictions. That would obviously make sense in our website sign-up sort of situation. But the reason the response was a bit slower there was because this model isn't being used all the time. So AI Platform recognizes it can just persist everything down to disk and wait for a new request to come in before it spins up hardware and ends up costing us money. So we've got our predictions back. These photos should be pretty familiar to you. We saw them earlier. And you can see 100% here is telling us that we're very confident that these pictures are fake. You can see a familiar person. I'm the wrong way around. So this is me on my first day at Doit. I've got my Google Cloud Data Engineer hoodie on, but it's correctly identified me as a real person in a few different examples. We've made one error. And this is on the photo, actually, interestingly, that everybody thought in the poll was the most likely to be fake, which kind of demonstrates, I guess, that what the model learns and what people intuit is, quite different. I think if you look just at the face, this face is quite a believable face, but the context of it, the right-hand side, sort of gives it away. It's really interesting. I guess like another piece of work would be to drill down into what the model has learned. Can't really do that today, but there's a sort of a good opportunity to look at that there. So this is what a deployed model out of TFX could do and would look like in production. So I want to just touch back onto the Kubeflow side of things. So we've talked about TFX and what that does and each of the different components, but I want to sort of cover a little bit how a component and an orchestrator interact. TFX has an abstraction called the Metadata Store, which is about storing the raw data that you're working with and the data in the different steps through your model pipeline, and also some of the provenance, some of like where that data came from, the history of your training, and it can do that in a database. So every TensorFlow component is made up of a driver, an executor, and a publisher. So the driver is the input into the executor. The executor runs the work, and the publisher publishes that back to the metadata store. And this enables TensorFlow Extended to call out to an orchestrator like Kubeflow to do the work in the executor, and that's how it interacts with its orchestrators. And so on the left-hand side here, I'll show you this in a second. In the Google Cloud Platform console, you can see the graph that we executed to train the model that I just showed you making predictions. And as you can see, it goes through the graph. It can do some of this work sequentially. For example, you can see example of validator doesn't depend on any of the other, isn't a dependency for any of the lower down items in the graph. So you can actually do your transform step and your evaluator step at the same time. And obviously these graphs, if you're familiar with Airflow or Kubeflow, these DAGs can get a lot more complicated. You may have multiple models feeding into each other. And so this is quite a nice way to reason about how your model's behaving. Another nice feature of this is because the metadata store has all of the provenance around model runs that you've done in the past. If you submit a new job via TFX to Kubeflow, and some of those steps have already been run and there's been no changes to that data, it can just take the results from the last run and skip that step and take the results that it's got in the store. That means you can be very efficient and sort of a bit more sort of risk-seeking in the way that you implement things. You don't have to worry about having to start right from the beginning if you're building a model up as you go. So I'm just going to, before the questions, I'm just going to sort of jump into Kubeflow pipelines and just show you that as well. So you can navigate each of the nodes of this graph and understand the artifacts that it's produced. This is the inputs and outputs that we've worked with across all of our data. You can see, for example, here that we've got on the resolver node, this is responsible for loading. I didn't actually mention this component. This is responsible for loading an old model and comparing that old model with our new one. And that provides, as you can see, the model blessing. And so this is the Kubeflow pipelines interface. That's what you get if you come into Google AI Platform and you go into the pipeline section. You'll land here. I've already installed a pipeline, and the fact that AI Pipelines is in beta means that it's really straightforward now to deploy a Kubeflow instance to either an existing Kubernetes cluster if you have one, or a new cluster that you can specify the setup of yourself. And so just with a few clicks, I suggest you always tick this allow access to the flowing cloud APIs, because that's what allows you to submit work to the Kubeflow cluster. And then you're off to the races. You can start submitting work in to a Kubeflow cluster, and if you go through those steps, you'll end up with something a lot like this. You can then go into your Kubeflow instance and start submitting in jobs. So I think that's it. I think I've answered one of the questions in the chat. If there's any more, I've got a bit of I can concentrate now a little bit more on those. So please ask away. I'll give you a bit of time to come in with any more questions.
I'm just going to open up another poll as well, just to get some feedback from everybody about today's presentation and how you'd like us to deliver these presentations in future. But thanks for that, Darren. It was fantastic and really, really interesting.
Great, thank you. Yeah, so I think we're really interested in iterating and working out what the best way to deliver these talks are. we've done like 4 or 5 Zoom talks now, and we've maybe found some of the issues that we have with the platform. So open to other ones. We're thinking about YouTube, I think, for the next one. But,
I know there's been a lot of people who's had problems connecting on Zoom in the past, so we want to make it more accessible, really. So we're looking at different bits and pieces to go along. Not everybody's got a laptop with permissions to install things like Zoom. Some corporate profiles block it and that. So we really want to make it as accessible as possible. Keep that interaction up. So we've got a question on here. Can you share a recording of this meeting? Yes, absolutely. We just need to do a little bit of editing, and then we'll push them out next week to our YouTube channel. If you follow our Twitter account, which is, I'll tell you in a minute, at Doit INT, you'll be able to see when we announce when we push those out. Just put the Twitter handle in the chat as well if you want to copy that. So there's another question here for you, Darren. So this is from Andrew. What features do you think Google Cloud will add in the future to support this approach?
Yeah, so I guess one of the I touched on this briefly in the course, in the talk, but the notion of online versus batch predictions. So one of the areas that Kubeflow maybe struggles a little bit more, hasn't quite been implemented yet. I think they started to implement it and then backed out, is to support a batch prediction requirement, which I think, as I hopefully motivated around running that prediction across all of your users, is a valid kind of thing that you might want to do. People often think about the online case, but not so much about the batch one. So Kubeflow doesn't currently support that, but AI platform does. So there's quite a lot of functionality to sort of think about there. That's something that we see a lot with some of our clients, is wanting to think about how they can achieve batch prediction using AI platform and just using their models in general. So AI platform supports it. Kubeflow currently does not, so you probably would want to think about using AI platform if you had a batch use case. In terms of features that are in the future, I know there are a few things coming in different areas of AI platform. I think there's a big focus on BigQuery AI at the moment. So it currently supports a lot of different sort of regression and other kinds of models. I know they're going to be adding in some new kinds of models into that, so I would look on there. So BigQuery ML is much more about taking data that you've got in BigQuery, and it's a very easy sort of entry point to building maybe your first machine learning model in your company or for the data set that you're working with. And it's a really good first point of call. And so the kind of modeling that I've talked about today makes sense if you understand your problem very well. Your problem is novel, you can add value to it. But there are a lot more tiers to there are other lower hanging fruit that you might want to focus on, and the Google AI platform sort of fits in different ways for all of those different things. So you've got probably the best place to start is, especially if you're working with tabular data, BigQuery ML. The next sort of pip up from that is if you've got quite a standard problem, possibly a little bit like this one, you could look at AutoML. AutoML is the platform that sort of encapsulates image, text, speech, video, I think also tabular data. And if you've got a model, if you've got not a lot of data, but you want to train a machine learning model, you can take your existing small data and use something called transfer learning, which is taking an existing model and kind of perfecting it for your data, and use that. And then I think the next step up from there, if you've got a lot of data and you're pretty sophisticated, you have a dedicated team for this, you could take the step up a bit like I have today and use the sort of AI platform directly, which is more about you're sort of on your own then, you're building your own model, but you can leverage Google's scale to do that. And I think all of what I've just described also is available on SageMaker and other cloud products, but specific to GCP, that's sort of the how you would sort of step up from zero to hero. So I hope that answers your question. And 63% of people want it on YouTube. That's a good result. People still keen on Zoom though. So yeah, I mean, I think this is definitely an open issue for us. I don't think we've decided quite now. We've definitely experimented a fair amount with Zoom. So I think sort of trying to get something working with YouTube, which I think we tested a little bit this week, but we wanted to honour the commitment we'd made to do this on Zoom today. But some of our future meetups may be available.
Awesome. Thank you very much, Darren. I think we'll close the call up now, and we'll share the video if you want to watch it back later on YouTube next week. So you'll be able to watch that at your leisure. And if you're over in Australia, you don't have to watch it at 1:30 a.m.
Yeah.
I'm quite impressed by the dedication there.
And I've just got a quick last side just to say thanks to all of you guys for joining, especially from Berger, joining all the way from Australia. Thanks to Doit for hosting the event. And like one of the best things I think about working at Doit is the people. And 3 of my colleagues helped me out with this talk. So Gad Ben-Ram, Jason, and Rick, both on the call, help me in different ways. So thanks very much for them. And go to the meetup site and sign up for, if you're joining from someplace else, then obviously find the one that's local to your geography. But we'd really love to have you. And obviously when the current circumstances subside, it would be great to meet up in Victoria and have a physical meetup as well. Cool. Thanks very much, everyone.
We'll definitely keep sharing these videos even when it's back in person meetup as well. We'll always keep a live stream going now. I think we've learned that it's great to be able to interact with everyone around.
We really like doing it. So yeah, exactly. It'd be great to keep it up.
Yeah. Thanks everybody, and have a great evening. Stay safe, and thanks once again, Darren. That was fantastic.
Cheers,
everyone.
Thank you. Cheers, Darren.